Hello everyone, welcome to our channel Way to Learn. My name is Arijit Pal. This is the second video on microprocessor 8085. In the previous video of microprocessor, I have discussed the introduction and evolution of microprocessor. If you have not watched it yet, then give it a try. You can find the link in the description box. Today, I will start the first part of architecture of microprocessor 8085. In this video, I will explain arithmetic logic unit and timing and control unit with pin configuration. Remaining part will be in the next video. So let's start. I think when you hear the name 8085 microprocessor, then a question arises in your mind, that is, what is 8085 microprocessor? So the answer is the 8085 microprocessor is an 8-bit NMOS microprocessor that can deal with the memory of 64K byte. This microprocessor consists of 40 pins as well as work with 5V power supply. This processor can be worked at a 3 MHz of maximum frequency. This processor is available in the three versions such as 8085AH, 8085AH1 and 8085AH2. It has 80 basic instructions and 246 opcores. This is the block diagram of Intel 8085. It consists of three main sections: an arithmetic and logic unit, a timing and control unit, and a set of registers. The arithmetic and logic unit performs all the arithmetic and logical operations like addition, subtraction, logical AND, logical OR, logical exclusive OR, complement, that is logical NOT, increment, decrement, left shift, rotate left, rotate right, clear, etc. Timing and control unit is the most important part of the microprocessor. This unit controls the maximum performances of microprocessor. The timing and control unit is a section of CPU. It generates timing and the control signals which are necessary for the execution of instructions. It controls data flow between the CPU and peripherals, including memory. It provides status, control, and timing signals which are required for operation of memory and input-output devices. The entire operations of microprocessor and peripherals connected to this unit. So the control unit acts as a brain of the computer system. These are the pins configuration of timing and control unit. X1 and X2 are input terminals to be connected to an external crystal oscillator, which drives an internal circuitry of the microprocessor to produce a suitable clock for the operation of microprocessor. Clock, it is an output for user, which can be used for other digital ICs. Its frequency is same at which processor operates. Ready, it is a signal sent by an input or output device to the microprocessor. This signal indicates that the input or output device is ready to send or receive data. The microprocessor examines ready signal before it performs the data transfer operation. A slow input or output device is connected to the microprocessor through ready line. When ready is high, it indicates that the input or output device is ready to send or receive data. When ready is low, the microprocessor waits till the ready becomes high. The microprocessor examines the status of ready signal in the second clock cycle of machine cycle. This machine cycle I will discuss in next videos. Hold, when another device of the computer system requires address and data buses for data transfer, it sends hold signal to the microprocessor. After receiving the hold request, the microprocessor sends out a HLDA, hold acknowledge signal, to the device. Then the microprocessor leaves the control over the buses. The microprocessor regains the control over the buses after the hold signal is removed. HLDA, it is a hold acknowledge signal sent out by the microprocessor after receiving the hold signal. It is sent to the device which has issued the hold signal. After the removal of the hold signal, the HLDA goes low, and thereafter the microprocessor takes over the buses. Address latch enable ALE. It is an address latch enable signal. It goes high during first clock cycle of a machine cycle and enables the lower 8 bits of the address to latch either into the memory or external latch. Basically, ALE assists in demultiplexing the data bus as well as low order address. This will go high through the primary clock cycle as well as allows the address bits with low order. The address bus with low order is added for memory, otherwise any exterior latch. IO or M bar, that is input output or memory bar. It is a status signal which distinguishes whether the address is for memory or input output. When it goes high, the address on the address bus is for an input output device. When it goes low, the address on the address bus is for a memory location. S0, S1, these are status signals sent by the microprocessor to distinguish the various types of operation. When S1 and S0 are 00, operations are halt. When S1 and S0 are 01, operations are write. When S1 and S0 are 10, operations are read. When S1 and S0 are 11, operations are fetched. RD bar, that is, when microprocessor reads data or codes from a memory location or an input device, it is called read operation. RD bar is a signal sent by the microprocessor to the memory or input device to control the read operation. When it goes low, the selected memory or input device is read. WR bar, when microprocessor sends data to a memory location or an output device, it is called write operation. WR bar is a signal sent by microprocessor to the memory or output device to the control write operation. When it goes low, the data which is on the data bus is written into the selected memory or sent to the output device. Reset in. It resets the program counter to 0. It also resets interrupt enable and HLDA flip-flops. It does not affect any other flag or register except the instruction register. The CPU is held in reset condition as long as reset is applied. Reset out. It indicates that the CPU is being reset. I hope this will be helpful for your study. In the next video, I will discuss about the registers of microprocessor 8085. If you have any questions, feel free to ask me in the comment section. Like the video and subscribe my channel pressing the bell icon. Thank you.